Page 5 of the functions addendum. Number 5, use the modulus of a equals a or negative a. If a is greater than or equal to 0, it's a. If a is less than 0, it's negative a. To write the following functions without the modulus sign. Hence, graph each function. So, for the first one, oh my gosh, okay. Let's rewrite this. So we're going to say, actually, x minus 2 modulus is equal to x minus 2 if x minus 2 is greater than or equal to 0. Let's rewrite x minus 2 is greater than or equal to 0. That's the same thing as x is greater than or equal to 2, right? All right? And then the bottom one's going to be negative x minus 2, or we could say negative x plus 2. If x minus 2 is less than 0. Oh, but that would be the same thing as adding 2 to both sides. We'll get x is less than 2. Okay. So we've defined the function in two pieces, depending on if x is greater than or equal to 2 or if x is less than 2. Let's try to do the same thing with y, or c. So this would be negative x if x is greater than or equal to 0. And it would be negative x, because the absolute value sign would be active and make whatever x is the opposite. So actually that's equal to positive x. If x is less than 0. E. This would be equal to, if x is greater than or equal to 0, it would be x divided by x, right? Because the absolute value would do nothing in this case, and which is the same thing as 1. If x is greater than or equal to 0. And if x is less than 0, then it would be negative x over x, which would be equal to negative 1. Okay. Last one. So this would be if, this would have multiple cases. So it would have one case if x is greater than or equal to 2. And there's one case if x is between 0 and 2. And finally, there's a case where if x is less than 0. Okay. So, if x is greater than or equal to 2, then this absolute value sign would do nothing because the inside value is positive. This absolute value sign would also do nothing because if it's 2 or higher, it's also positive, right? So in the case that if x is greater than or equal to 2, basically you have x plus x minus 2 because the absolute value signs don't do anything, which is the same thing as 2x minus 2. Next one. So if x is between 0 and 2, then for this case, x minus 2 would be a negative value, right? So if this is a negative value, then the absolute value sign would make the contents negative. Now this here, if it's between 0 and 2, would do nothing. So this would be equivalent to x minus x minus 2. Which is equal to x minus x plus 2, which is the same thing as 2, right? So I'm going to make this one equal to 2. And then the last one, if x is less than 0, both this one and this one, the absolute value sign would take effect, and they would be negative values. So it would be negative x plus negative of x minus 2. And this is equal to negative x minus x plus 2, which would be negative 2x plus 2. Negative 2x plus 2. So it would be negative 2x plus 2. Okay, moving on. Modulus equations and inequalities. So these are properties of modulus function. Maybe some will be obvious, but we'll go through them. The modulus of x is greater than or equal to 0 for all x. Okay, that's pretty obvious. Modulus of x squared is equal to x squared for all x. Yeah, because if you have x squared, basically you're taking the modulus of the result, or the x before you multiply it, because x squared is always positive, right? And basically what modulus does is it makes anything a positive number. Modulus of the quotient xy is equal to the quotient, or the modulus of x divided by the quotient of y. That makes sense too, right? Because like if you have something divided by something, you find out if the quotient is negative if one of the two is negative, right? But if you're taking the modulus of the result here, then it's kind of the same thing as taking the modulus of each one before you divide it, because in all cases it will be positive. So that's not too difficult. This one here we have the modulus of a value is equal to the modulus of the opposite of the value, and that makes sense too, because you're always making both sides positive. So one of them is going to be negative, one of them is going to be positive. You're making both of them positive, so they are going to be equal to each other. Okay, and the modulus of a product is equal to the modulus of each one, the modulus of each component of the product multiplied together, and that makes sense too, right? Because like you can find a positive number by taking the absolute value of the two numbers you're multiplying together, or you could multiply them together, get a negative number, and then just take the absolute value of that. So either order is fine. And finally, the modulus of x minus y is equal to the modulus of y minus x. If you subtract two numbers, one of them is inevitably going to be bigger, but if you're always taking the modulus of the result, it doesn't really matter if you subtract in which order, because if you come out with a positive number, you leave it alone. If it comes out with a negative number, you take the modulus, and it becomes the same as a positive number. Okay, so those are all kind of obvious. Since modulus is the positive difference between two numbers on two positions on the number line, they call it a distance. It is clear that absolute value of x equals 2 has two solutions, x equals 2 and x equals negative 2. So in general, if absolute value of x equals a, where a is greater than 0, then a, and then x equals positive a or negative a. So we'll say plus or minus a. 1. Solve for x. So if the absolute value of x equals 3, then there's two cases. One is that x is equal to 3, and the other is the case where x equals to negative 3. Either one of those would yield a positive value after you take the absolute value of them. C. If the absolute value of x equals 0, then we know that x equals 0, because there's no negative value of 0, right? Here we have the absolute value of 3 minus x is equal to 4, okay? So there's two cases. One is that maybe the absolute value is doing nothing because the inside is positive. So we'll say if 3 minus x is positive, or 0, then 3 minus x, parentheses, not absolute value, is equal to 4, right? So then we know that x is equal to 3 minus 4, which is negative 1. And if 3 minus x is less than 0, then the absolute value is doing something. So we're taking the negative of that of 3 minus x. And let's see, 3 minus x equals negative 4. X equals 3 plus 4, which is 7. So in that case, if 3 minus x is less than 0, then the solution is that x equals 7. Okay, so these are the two possibilities. X equals -1 or x equals 7. Let's go to G. It's a similar type of problem. Basically, we're going to have 3x minus 2 is equal to 1, or we'll have negative 3x minus 2 is equal to 1. So 3x minus 2 equals 1 is 3x equals 3, x equals 1. And negative 3x minus 2 equals 1 is negative 3x plus 2 equals 1. So negative 3x equals negative 1. So x equals 1/3. Okay. Finally, letter I. Absolute value of 2 minus 5x equals 12. So this is 2 minus 5x equals positive 12. And the other option is 2 minus 5x is equal to negative 12. Or the negative of this is equal to positive 12, and then we just multiply both sides by negative 1. So let's do the algebra here. We'll have 5x equals 2 minus 12, so we'll have 5x equals negative 10. X equals would be 2? Yeah, negative 2. Okay, and this one would be 5x equals, positive 12, 14. So x is equal to 14/5. Okay. Number 2, solve for x. Absolute value of x divided by x minus 1 equals 3. So we know that one of the cases is when x divided by x minus 1 is positive, we'll have x divided by x minus 1 is equal to 3. And the other case would be when x divided by x minus 1 is a negative number, then we'll have negative x divided by x minus 1 equals 3. No absolute value sign because we replaced it with a negative sign. So for this one, we'll have x equals 3 times x minus 1. Distribute the 3, we have x equals 3x minus 3. Now we'll have 2x equals positive 3. So x equals 3 halves. And the other one, it's going to become x divided by x minus 1 equals negative 3. Then we'll multiply both sides by x minus 1, so we'll have x equals negative 3 times x minus 1. And then we'll distribute the negative 3, we'll have negative 3x plus 3. And for x equals 3, and x equals 3/4. Okay? Alright. And C. So we have absolute value of x plus 3 divided by 1 minus 3x equals 1/2. So we know that that is two cases. One is the case where the inside of the absolute value is positive, and then we just have this function here. And then we also have the case where the inside is negative, so then it would be negative x plus 3, 1 minus 3x equals 1/2. So for this one, we'll distribute we'll multiply both sides by 1 minus 2x, so we'll have x plus 3 on the left, and the right side will have 1 minus 3x divided by 2. And then we'll put all the x's on the left side, so it'll be plus 3 halves x on both sides, and it'll be, the left side will be 5 halves x, and the right side will be negative 3 plus 1/2 would be negative 2.5, or negative 5 halves. So you have, that's equal negative 5 halves, right? So 5 halves x equals negative 5 halves, x equals negative 1. Okay. And last of all, this one here. So negative, let's move the negative to the other side. It's a little easier if we put negative 1/2. The left side is just going to be x plus 3. And the right side is going to be negative 1/2 times 1 minus 3x. Oops. Okay. Let me get some more space here. So x plus 3 equals negative 1/2 times that expression in parentheses. We will distribute it. Like that. Then we're going to move all the x's to one side, so we'll move the x's to the right side. 3/2 x minus 1x is 1/2 x. We'll add the 1/2 to both sides, so we'll get 7/2 equals 1/2 x. Then we'll multiply both sides by 2, we'll get x equals 7. Okay. All right. Last three problems. Solve for x. 3x, absolute value of 3x minus 1 equals absolute value of x plus 2. Okay. Difficult, but let's just use their hint here. So if we have these two expressions, we know if we have 3x minus 1 equals an expression, absolute value equals expression, then we know that 3x minus 1 is equal to plus or minus the expression. So let's write that down. Let's write 3x minus 1 is equal to plus or minus the right side, which is x plus 2. So one case would be 3x minus 1 is equal to positive x plus 2. The other case is 3x minus 1 is equal to negative x plus 2. Let's analyze both sides. So in the first one, we're going to move x to the left, and we'll move the integer to the right. And then our solution is x equals 3/2. On the right one, we'll move x, or first we'll distribute the negative sign. Then we'll move the x to the left, so we'll have 4x. And then we'll move the negative 1 to the right, so we'll have negative 1. So our answer would be x equals negative 1/4. So the two possible solutions are x equals 3/2 and x equals negative 1/4. Let's do e. Same thing here, so we'll do 1 minus 4x is possibly plus or minus the right side. So let's do the positive one first, and then we'll do the negative one. And then we will distribute the 2. And then we'll move the x's to the right, and we'll move the numbers to the left. So we'll add 2 to both sides. So x is equal to 1/2. Or, let's distribute the negative sign. And then we will add 4x to both sides. So we'll have 3x plus 1. And then we'll subtract 1 from both sides, and we'll get 0. So x is equal to 0 would be the other solution. Okay, last problem. The C here. So x plus 1 is equal to plus or minus 2, plus or minus 2 minus x. So the one case would be x plus 1 is equal to 2 minus x, with just a positive. The other one would be x plus 1 is equal to the negative of 2 minus x. So this left one, it'll be 2x equals 1. We put all the x's on the left and we put the numbers on the right. X is equal to 1/2. And we'll have x plus 1 equals negative 2 plus x. And then we'll have, if we subtract x from both sides, we'll just end up with no x's. And then we'll move all the numbers to one side, and we'll end up with negative 3 equals 0. Weird. Okay, so this is impossible. So if if we are in this scenario, there are no additional solutions, okay? So the only solution there is this one, x equals 1/2, in the case that we don't need to find the opposite of either, or the absolute value does not take effect in either case. Okay? So that's it for page 5.